Now, new topic in this class is called exceptions and assertions, and I will try to explain you what exceptions are, what are different keywords or elements you can use to deal with exceptions in different ways. I will tell you different kind of exception types and hierarchy of them, what are checked and what are unchecked ones, custom exceptions, and also about assertions. And I will just mention one approach how you should build your software, which is called defensive programming. Exception is an event what occurs during execution of program that disrupts normal flow of instructions. And examples for exception is when you try to open non-existing file, non-existent I think in proper English would be, interrupted network connection, passed values outside valid range, trying to load non-existing class file, etc. And during these events, new Java object is created with specific type, and some of examples for these new Java objects could be null pointer exception, and this appears when you try to use some of object members, that means either properties or methods, to an initialized variable. So you have reference for this object, reference has only zeros inside it, or it has this null reference, and you try to get length of string, or you can try to get some internal property of object, but there is no actual object, there is only a reference which points to nothing, and you get null pointer exception. Sometimes I also call null pointer exception I'm learning Java exception. Then maybe arithmetic exceptions when you get some overflows or you divide by zero, input mismatch exceptions, etc. And then there are also errors, and errors class of Strouble I will show you later, and this may be input-output error or I/O error in short, when something gone wrong with input-output operations like reading, writing to file, etc. Assertion errors or Stack Overflow errors. About Stack Overflow errors, the meaning are usually following. If you are during development stage of your software, Stack Overflow error means that you went into infinite loop, and in particular set of infinite loop, because if you just do like for int e is 0, I do not know, larger than 0, and do something in this loop, you will not get Stack Overflow error, because in Stack you always introduce new local variables. You start with upper part of memory and you go down, down, down. And here, in such particular loop, you need to introduce new local variable int e. Somewhere here is your e. And you always rewrite it. You don't need to increase stack to introduce something new. So it will be infinite loop, but you will not get Stack Overflow error because Stack is not increasing. But if you will do something like, let's say, void clone, and here object O, and here you will just say clone the same object O. Here you create recursion with past parameters. Every time you call new method, if it takes either input or provides output, you need to reserve memory, either to pass values, here would be this O, or if you return value. Okay, for example, here you can observe how object to return. And when you call new method again, and somewhere here, either before that or after that, there is also a return address. How you need to continue when execution of this method is finished. And then when you call another method again, you store passed value, you make placeholder for returned value if you need one, and address in memory where you need to continue. And if you create a recursive method which calls another method into infinite loop, then you will have Stack Overflow error, because for each of these new calls to the method, new portion of stack is used for passed arguments, returned arguments, and address where execution should be continued. This is how many programming languages and also Java works. But for some languages, especially these languages which are using this functional programming or declarative programming in general, for these languages everything is just a method, and they do not have such iterators where you initialize initial variables and iterate them. And for functional programming, every time you need to iterate, you actually do recursion, and here you take something like next object. And for such programming language, they do so-called tile recursion optimization. It may be called just tile call optimization. That if compiler see that the same method which was already called is called again, so this is the same method and that is the same method, it doesn't increase stack, but overwrite the same part in virtual memory for past parameter, returned parameter if you want, and also to continue execution when this particular method is finished. So it overwrites the same part in virtual memory again and again and again, and then you will not get Stack Overflow error because you do not increase stack. And this is very important for functional programming because they do not have iterators, and if they would decrease stack all the time, and if you have 10 millions of objects to iterate in such way, then you have to have 10 millions of some amount of memory cells inside virtual memory. And this is one of the reasons why Java, until serious redesign, will not be fully functional programming language, because it always increases stack when new method is called and it doesn't do this tile call optimization. But sometimes if you are in maintenance stage and you get Stack Overflow error or heap overflow error, then in many cases it means that your application is too heavy and reserved virtual memory for your virtual machine is too small. So you need to change settings for this application and to increase total amount of memory. So now about genealogy of these errors and exceptions. Common ancestor or common class for errors and exceptions is called throwable, and then it divides into errors and exceptions. And there is difference. Difference is following, that if it is exception and it's not a runtime exception, then compiler already knows that such kind of exception may be thrown, and it requires you to deal with this possibly thrown exception. And dealing with this means either you declare that this method will throw this kind of exception, or you have to catch it and handle it. Errors are not checked during compilation time because in most of cases errors means that something went wrong in environment, not in your program yourself. For example, Stack Overflow error may be indicator that you went into infinite loop, particularly infinite loop with recursion or where you need to increase stack memory for each iteration. And out of memory error also may be that you are creating new objects into infinite loop. For example, you have some iteration and you do something like create new object, create new object, create new object in infinite loop. But in most of cases, when you are running it in production, such stupid errors should be fixed already. And this means that your application is just too big to fit into reserved virtual memory. So therefore errors in general means that something went wrong into your environment. So it's not fault of your program or application or your code, but it is fault in external environment. And then there are some of exceptions called runtime exceptions, which in general are considered logical errors in your code, but are still not checked during compilation time because it's too tricky and too hard. A typical example is null pointer exception. You may think that checking for initialized variable is very simple, but it's simple only for local variables. And for local variables it is checked. You cannot compile your code if your variables are not initialized. But when you have object inside object inside object inside object, like you have declared them in body of the class as a structure belonging to objects of this class, then it is very tricky, and therefore it's not checked during compilation time. So just a reminder, talk is about the following thing. So if it's local variable, I immediately get compilation error, so this is checked during compilation time. I deleted the wrong one. I have to initialize it. And here I will get null pointer exception, because it is initialized, but it's still initialized to the null, not new object. So here what I actually need to say something like this. But if I have it as a property of an object here, then I can even use it and compiler do not warn me. Not my object, but test my object. And I will very nicely get null pointer exception again. So that's about these runtime exceptions. Why these are runtime exceptions, not errors? Because ideologically or politically, errors are considered coming from outside world, from your environment, and exceptions are considered coming from your logical errors inside your code. In particular, runtime exceptions in many cases are still your fault and logical errors, but because these are tricky to check during compilation time, they are not checked, and therefore you may compile it nicely, it will still throw these exceptions. And here is some example how can you get array index out of bound exception, which is also a runtime exception, because in trivial cases, for example, to check how long array is easy, but this length of array may be checked and calculated dynamically, and if you do it dynamically, only way how can you know it exactly is to actually run your program. And how do you deal with these exceptions? Usually, if you know that there some error or exception may be thrown, you handle them, and you have try block, and inside try block you do these operations which may throw different kind of throwables, either errors or exceptions, and then you catch them. And you can catch different subtypes. You can start with more specific ones like IO exception, then just exception, then throwable, and handle them in different ways. And then you can have finally block where you do cleanup, something like this. And usually in this finally block you need to release different kind of resources. That means if you write from file, you should close reading, especially writing into this file. If you did something with database, you should close connection to the database. If you did a network connection, you should close this network connection. Because if you don't do this, particularly for files, I think that for modern Microsoft Windows systems this is fixed. But in old times, there are so-called log files to indicate that some file is locked for writing. So you have some file, .txt, you write to it, and operating system creates lock on this file that nobody else can write to it. If it's some kind of database file, this lock may be not to entire file, but to some page of file, like, I do not know, customers, Microsoft database. Then these locks are to 4 kilobyte size of pages inside this file. And that means that either you cannot write to entire file if it's locked for entire file, or in some particular 4 kilobyte pages. And for older Windows, problem was that inside this lock and inside Microsoft Windows there was not a checking mechanism to check is this process still alive which locked this file. And you created some stupid application which created lock to the file. Application crashed, this lock remained. Nobody else could write either to entire file on some particular page inside this file because of this crashed application. For Unix-like systems it was from beginning all the locks always had process ID put inside this lock. An operating system checked, is this process ID still running? Or if not, it just removed this lock file. But for old school Microsoft Windows, when I had to maintain such servers still to Microsoft Windows 2000, only thing how can you deal with this was to reboot Windows servers each night in general, or sometimes even more frequently if you had to deal with some buggy and unstable applications. So that's about files. If your operating system do not care properly about lockings, then you lock some file when you write, your application crashes, application do not recover from this properly, nobody can write to this file. If you do as a database connection or just network connection, again, to do this interaction, server needs to remember different things about your particular connection. If you create connection and then your client dies, server still need to remember different things. Send packets, receive packets, session ID, and different things. And it takes some amount of data, and if you do not gracefully close this connection, you voluntarily or involuntarily do service denial attacks, because every time you create connection and do not gracefully close it, then server needs to remember more and more things about more and more connections. And of course they deal with this usually if this connection is dead for some time, depends on server configuration, maybe minutes, maybe hours, then of course they release this data. But it's still important that you release these resources after some crash. And so if some throttle is thrown inside this try block, then execution of this block is immediately halted, and this block is and this created exception is provided to handlers. A little bit about handling. So exception is just a Java object or throwable in general. So it has some internal fields like message field, cause field, and other things. And you can just create new exception like anything else. But if you will just create it, it will be just another Java object with some structure inside it. But when these exceptions are occur, what actually is happening, these are thrown. And what means throw? There are many additional threads running in Java. One which you already should know is garbage collector, but another is exception listener or throwable listener. And when you throw, you use this keyword, you provide reference to this throwable listener or exception listener to handle it. And when you throw it and you provide it to this handler, then it starts handling it. This means normal flow of operations is interrupted or stopped, and then it is handled. And it's handled in following way. For example, you have main method as initial start, then you call method 1 from it, method 2, method 3, and method n. And here you get this exception, which is thrown. If you have catch block here, then this exception is handled in this catch block, and it does what this catch block told it to do. If there is no catch block to this, then the same exception is provided to handler for method 3. If that has catch block, then it's catched and handled here. If not, then it's provided for catch block to method 2, if not to method 1, if not to method main method, and if there is no catch block in method mind, then entire thread of execution stops. And depending on what is the default settings, usually it shows stack trace on standard output or standard error. But if it's somewhere here is catched and handled, then this particular thread still continues. So, and if your application was single-threaded, then entire application is stopped if these exceptions were not catched and handled. Of course, you know that in old school English, catch in past is caught, but in regular English, of course, catch is catched. And I think that our contribution to English should be to regularize as much as possible, because these irregularities do not add any value to the English language. So, if it is single-threaded application and some thrown exception was not catched, then entire thread is stopped and your application is stopped. And then if somewhere it was catched or caught, then if there was finally block, then finally block was also executed after that. Particularly starting with more recent Java versions, you can catch different types in one catch block with OR condition here, and you can also do so-called try with resources. For example, when you need to reserve some resources and release them in finally block, you can make your code shorter, that for try, after try keyword you open close normal brackets and you initialize all needed resources inside these brackets. Then you don't need finally block, because everything what was initialized after try and before body of the try, these are something like parameters for try. Then all these resources will be released automatically, so you don't need a finally block. For beginners it may be a little bit harder, but code becomes shorter, and shorter code in general is always good. And you may decide to not handle exceptions in particular level of method for different reasons. And one of the reasons is following, that you already anticipate that bad things may happen. You have main method somewhere here, which calls something else, and then you have some like validate method. And then this validate method calls like step 1 method, step 2 method, step 3 methods, etc. to validate. It may be validation of XML file, it may be validation of other data structures, it may be validation of users and accounts. For example, you go with valid username and password, but you also need to check do you have enough permissions, etc. And then you may decide that if all of these different steps may go wrong, you may not want to handle all particular errors which may go wrong for these bodies of validations in 3 or 4 or 5 different places. So you just say that this will throws exception, this throws exception, this throws exception, and you try and you call them step 1, step 2, step 3, and then you catch everything in one single place. And for example, if this throw is this message or whatever, maybe type of exceptions is still the same. So then instead of 3 different places where you need to handle your different errors, you have just one single place here in this method in step above. And this is one of very typical examples when you may decide that instead of dealing with them immediately, you will handle them separately. So now a little bit about inheritance. Exceptions are another output for your methods. For example, you have some method 1. Here is your input parameter like string and object as returned type, but exceptions are another output. So this is in, this is out, but if you throw some exception and either you declare it, then this is another output for errors, and that means that if, for example, you extend some class, again remember, you can always make input wider. For example, you override it, that input may be object, your output may be narrower, for example, it is just a string, and this is another output. For example, if here it was declared that it is exception, you may say that in this case, when you override, it will be just I and O exception. And that's what you need to remember, inputs and outputs on this funnel. So this is in, this is out, nothing bad will happen if input will be wider and output will be narrower. An exception is just yet another output. And here is some code example where you deal with different kind of exceptions. So test A throws runtime exception, test B throws arithmetic exception, and test B1 throws just an exception. And also what is important here is, do you deal with checked exceptions or unchecked throwables like errors and runtime exceptions? If these are runtime exceptions or errors, you are not required to say that it will throw some kind of throwable, because compiler doesn't check it. Because checking is hard, only thing you can actually check it is during runtime. So you will still be able to compile it, but if some of these unchecked exceptions or errors will be thrown, then you will get some strange behavior because you didn't anticipate these errors or runtime exceptions. But if you talk here or deal with checked exceptions, starting with exception and everything else which is not runtime exception, then you will not be able to compile your code because this is checked during compilation time. And then you may create your custom exceptions, and you are always encouraged to create custom exceptions, because this is proper way to notify when something went wrong. For example, about Java, they introduced null not because it was very needed, but because it is very easy to implement for compiler. And null in general is very bad thing, because null is the same for any data types. If string is null, it's the same. If object is not null, it's the same. If your customer is null, it's the same. So null actually do not have type. And Java is strongly typed language except null reference, because null reference do not have type. And that means every time you get null or pointer exception, you actually do not know where particularly, for which particular object you got this particular exception. And therefore, one of school of thoughts is you never actually should use null. You always should return a real object like customer. And so here the question is what kind of data structures you have inside. For example, you may what to do, for example, for errors. And one of the options is, for example, that you search for customers and you got error, you return strange customer. For example, customer with identifier which is out of scope, with some strange names, etc. But then, of course, you may ask, but what if I have such customer with such fields which should be valid customer? Answer is here, throw exception. And so proper way to do is that instead of errors, you do not return null, so you got error, you throw exception instead of returning null. And not error, you return properly created object. Of course, it takes a little bit more time to write your code for this part, for catching it, etc. But as soon as you start working in large projects where you need to integrate systems, remember that returning null in error case is very bad idea because nulls do not have type. And searching where exactly this null pointer occurred is very hard. But if you throw exception instead, then you very easily see that either you get proper returned customer or you got exception. And then exceptions may be extended, and then you have even more information what exactly went wrong, because then you can get quite a good information about what were wrong with type of exception. If you have something like my up exception, you even know from this type of exception where exactly it happened, so talk is about your application, not about some other application, etc., etc. And similarly to everything else, you may introduce new internal fields for these exceptions that you extend, and usually you extend exception because you usually deal with checked exceptions which you want to check during compilation time. Sometimes you may extend errors as well, but in most of cases you extend normal exceptions which are checked during compilation time, and then you can get quite good bit of information just by type of this thrown exception. And yeah, then I told you, if you just construct some throwable object or exception, it is like any Java object. You can do whatever you can do with it, not much, because all these internal fields for throwables are immutable, so not changeable. You can change them only during construction time. But if you throw them, then they are handled with this separate thread which handles exceptions. And then when you do different kind of validations and you decide that this is wrong, you throw your own custom exception, and then everybody who runs this application got much more information what exactly went wrong than just returning null for this variable, like when you try to get some kind of connection. And what you can do with these throwables, each throwable get two internal fields, cause, actually three, cause, message and localized message. Usually you use only message, but if you also do implement multilingual applications, you may put default language in message field and localized language in localized message field, and then you may use them, for example, to show user readable error on screen for real user. And then there is cause field which shows initial initial error or trouble in general. What is cause and why do we need it? For example, if we start with main method and then we call one method and another method, and we deal with checked exceptions only, just means everything should be nicely declared during writing code and before compilation. For example, here this method says that it throws IO, let's call it exception. I do not know, is this really IO may be error, but let's talk about exceptions. Throws. And this throws validation exception. And in method 3 you get something like null pointer exception. Then you have to catch it and handle, because you cannot throw it to this method, because here only thing you can throw is validation exception, because it will be outside of these outputs, outside of agreed range of types, and that means you'll get some kind of runtime error. But what you do when you catch it, you can just throw new validation exception, so this type, which is allowed to be thrown, and as a cause you put this original catched exception, null pointer exception, and again here either you handle it, or if you cannot handle it because it's some very serious errors, then again you can throw IO exception, and as a cause you put this, so you take this, and as a cause you put this validation exception, and then everybody who analyzes this log sees that initial error cause was this, was not possible to handle here, was not possible to handle here, and you see all chain of events how it happens. It's something like in physics, probably I have told you already, that initially I studied theoretical physics, not computer science, and in theoretical physics you have some phenomena, or phenomenon in singular. And okay, let's be modern and say this is collapse of two black holes. Two black holes rotate and collapse here, and they make gravitational waves. And of course, even though it's very powerful, when we are far away we cannot feel changes in gravity in any considerable way, and here we want to feel them. And what is physics all about? Physics is all about to convert this physical phenomena into senses which we can do, that is see, smell, touch here, and we have 7 senses in general. And so here you need to have some machinery to change this into that. And in physics, one of our teachers told it is like recoloring elephants. And this recoloring elephants is, I think, very useful, especially for us as a young physicists, was following that. Anecdotal story was following that missionary goes to some Africa to local guys and teaches them to Christianity or whatever, and sometimes they talk about life and everything. And this guy asks these local guys, how do they hunt elephants? And they say that they hunt elephants in following way. That there are two types of elephants, blue ones and pink ones. And let's say blue ones would look something like this. So, blue elephant walks somewhere in savannah on the road, and they are very smart, but they are very simple-minded lētecīgs. Okay, let's call it simple-minded. So they can read, but they believe, like many Facebook users, to everything what they read. If you put some sign here on T-junction of road that blue elephants turn left, oh, this is actually right. So blue elephants turn right, they can read it, they are smart, but they are simple-minded and they follow instructions. And here you dig hole, you put stick in this hole, and they go to this road, fall into this hole on this stick, and they die, and they have meat for their village for an entire week. But there are other types of elephants, these pink ones, which are not so simple-minded. If pink one would read this sign, just turn right, then they would not follow these instructions. But good thing about these pink elephants is that they are very easily to be offended. And if you, before that sign, you make another sign like pink elephants are stupid, they get offended and they get hungry about this, angry. And when they get angry, they get blue because of their anger. And when they got blue, of course you catch them like any blue elephant. And what is moral of this story is that if you know how to handle these blue ones and you get pink ones, then you just need to convert these pink ones into blue ones and you are done. And for gravitational waves, how we are done? So we can just hear, smell, touch and see something. We convert these gravity waves into light using lasers, whatever. Then we convert this light into electricity. Then we amplify it and add speaker to it, and then we can hear it as a sound, because it happens to be that usually black holes merge together and they make frequencies which we can hear somewhere in between 20 Hz and few kilohertz. So we recolor these elephants from gravity waves to light waves, from light waves to electricity waves, from electricity waves to sound waves, and we are done. And similarly here is about these exceptions. So if only thing you can handle is like these yellow elephants, and you get some red elephants here, you need to convert them, or in this case wrap them up into skin of proper elephants, and then you are golden. And how does it look in real life? Usually, okay, we can check it out. There is one Java Enterprise system which I am running on my server, which is XWiki content management system. But recently, there are not much of what is today's date. Now maybe it will be enough to see here. because looks like it was enough abused. But still no caused by. Then we have another server which is properly abused. Unfortunately, here I cannot show you good example of real example for Java Enterprise systems. But in general, in log file it looks like this. You got some exception caused by some other exception, caused by some other exception, caused by some other exception. And this caused by means that you got some kind of exception, but initial source of it was some other exception, and initial source some other exception, until it was either somehow caught or this particular thread was actually stopped. So, and then you can print stack trace. This means it will show you show stack trace here. So here there was some output for bringing out stack trace. Here, connection reset at, and we will talk about this later. So far you know that everything starts with main method, but for multi-threaded application, particular thread starts with run method. So this is like main method for particularly newly created thread. So it started from here, and then it called that method, it called that method, it called that method, and actually it got socket exception here in this particular Java file, in this particular line. So this how this printout of stack trace looks like. So you can print stack trace, you can get it and then print out for log, and you can get a class name where this exception occurred file name, because there may be inside inner classes. So usually there is one-to-one relationship between class name and file name, but maybe also different line number where it occurred and method name. And as you showed you here, you can read all this data like here. So this is class, this is file, and this method here, and in this particular line of code. And if there are more than one class in file, then this file can be a little bit different than this class here. And here is one. And then, by the way, if you are constructively lazy, you can just convert any throwable to string, then it will show in which class it was created and will print out a message field. And that's about exceptions. Now about assertions. Assertions are a completely different thing, but they are related in a way that it is still about error handling. And assertions in Java are assert keyword, where you put some Boolean expression here. And short notation is just assert that something is true, and if it's not true, then assertion error will be thrown. And other more elaborate cases, assert for some expression, and if it's not true, then assertion error will be thrown, where this expression will be put, and this expression should be string in general. But of course, if it's not string, it will be converted to string implicitly. And this expression will be put into message field of this assertion error. And what is important about assertions is that you can enable and disable them during runtime. And assertions were introduced because of following problem. If you use some old school programming language like BASIC, Pascal. And for Pascal, you write quite a lot of code, and here you have some error handling. For example, you write into file, you need to check does this file exist? Do you have permission to write to it? When you write it, it may happen that you do not have enough free disk space, etc. And you may check also, do you have actually some folder, etc. And you have quite a lot of code to handle these errors. But then you decide that most of these errors will actually not occur when you put it into production, because this error should be handled only in test environment, which is unstable. So this is unstable environment. What you can do, one of things usually is that you never just comment out this entire block, because when you comment it out, it may happen that you comment out it improperly and you will introduce some bugs. Usually you do something like this: if, let's say, testing and blah blah blah, and then you have some common variable, you switch this testing from true to false. If it's testing true, you do this; if it's false, you don't do. So you introduce this global variable. And it may be testing, it may be debug, blah blah blah. And it is quite ugly, because you always need to remember if debug or testing and blah blah blah. And in Java, assertions do the same thing. They assert only if assertions are enabled. So if you have development environment, testing environment, you assert. If these are disabled, it just skips in runtime all these messages. And you enable assertions with parameters for Java Virtual Machine, or you can change it also during runtime if you like using API. And so assertions are just more user-friendly, better implementation of these global switches. Do you need to check it in this particular environment or not? And then in your practical exercise you will see that sometimes your business requirements are written in a way that you need to assert for bad cases. But in Java you have to assert for good cases. And if you think that conversion from bad cases to good cases is very easy, then you do not have enough experience with logic and Boolean logic particularly. For example, we have two variables A and B, both are Booleans, maybe true, maybe false. And if we say that good scenario is that both are true, then bad scenario is everything else, and everything else in this simple scenario is that one is true, another false, another first is false, another is true, and both are false. So if you convert one good scenario to bad, to opposite, you actually need to check for 3 different other cases except this particular one. And similarly, if you say that bad scenario is both are false, then true is everything else. Both are true, one is false, another true, another is true, another is false. And this is just 2 Boolean values where you can get only 2 different things for them. And if you have more and more rules with ands and ors, etc., then converting them to complete opposite, for example, this is good and everything else is bad, is very time consuming and error prone. And when I worked in testing, what I developed by myself, because in that time internet was not so full with examples like Stack Overflow, I find out that in these particular cases, when I need to test something, if business scenarios are written as bad cases, not good cases, I can do following: assert, and then write these bad scenarios, and if these bad scenarios were actually not true, then do complete opposite, assert false, and then so you start with if all these scenarios which actually represent these bad cases when you need to throw some assertion error, and then assert false. Because if you just want to use without if condition, then everything here from one scenario to another should be written as complete opposite of this Boolean logic, and it is very hard. And I will show you in practice how to deal with this, because in your practical exercise you also will got this problem that business requirements are written not for positive scenarios where you do nothing, but for negative cases. And now about defensive programming. So there is nothing bad if you write your pet program where only user will be you, that you do not care about abuse of your application, because you will know how to use it properly, and you don't need to care so much about the robustness of your application. But as soon as you start writing application which is publicly available in internet is harsh environment, and publicly available applications are always tested for their endurance and robustness using automated tools from different bad guys. And therefore, as soon as you start developing applications which are publicly available to everybody, you need to change your mindset that you need to implement not only that application works, that everything is passed to it correctly, but also that it fails gracefully when somebody tries to abuse it. And so this is called defensive programming. You need to check everything very properly about past inputs, about different other conditions, etc., etc. So every time you build publicly available solution, you need to be very careful about this defensive programming approach. And to prove my point, you know web server and website Odoo.lv, and of course it's neither Microsoft.com nor Google.com, but it's publicly available. And how does it look from... First, I showed you already that even though you think that this XWiki application works nicely, it logs quite a lot of different errors from different abusers when they test it out on robustness. So you see log is full of different kind of errors. And if I check, for example, this is not publicly available, but about different kind of errors here. For example, here is for last month what kind of different errors it got from abusers. And you see that there are quite a lot of different URLs, many of them are different kind of vulnerability tests for PHP frameworks. Because for backward compatibility in this website there is still PHP file, which is then redirected. Therefore, these different scanners still see that PHP is working on it, and they check different kind of vulnerabilities. And you got bothered about this banning IP address for this test server. But if we check how many these banned addresses were for these different kind of network abusers, you see, for example, how many IP addresses are banned for Odoo.lv web server. This is not... this is Odoo.lv. And particularly for tools. So for some reason this server is more abused. So here you see that approximately 1,000 of IP addresses are banned. And why are these banned? File to ban works in such a way that if there are too many authentication errors, then this particular IP address is banned. And this means they use these dictionary attacks to try to log into a system using standard usernames and standard passwords. So, and if you do not care so much about this, then your systems may be broken quite easily. And that's it from me about defensive programming as well. Any questions or comments?